Hello everyone, I Dr. Nikita welcome you in my pharma lecture series. Kindly like, share, subscribe my channel and post your comment for any of your required topic and your requirement. So we are going to see different properties of the colloids, the basically electrokinetic properties. So this includes the zeta potential, then electrophoresis, electro-osmosis and the coagulation or precipitation. We have seen how the potential is developed around the particle in my other video, then how the potential is responsible for the stability of the particle. Now, second, you have electrophoresis. It is the influence of electrical field on the particle. And under this influence, the particle movement is called as the electrophoresis. And osmosis is the movement of the dispersion media. So under influence of the electrical field, the dispersion media moves and this movement is called as the electro-osmosis. So when particle move, it is a phoresis, and when the dispersion media move, it is called as the osmosis. Next you have is the coagulation or precipitation and aggregation. As you know, the ideal system consists of the particle having sufficient zeta potential and the stability. They have repulsion with each other, they repel each other, and they do not come close and they do not have interaction overcoming the repulsion. Because of which the system is stable, homogeneous, there is no flocculation or aggregation of the particle. But when the potential is disturbed, the particle combine together and they aggregate to the coagulation and aggregation sedimentation of the system, and it leads to the instability. So how it is happening, that we will see in detail. So electrophoresis, as you know, the movement of the particle under the influence of electrical field. So here we have taken a U-shaped tube and we have taken a sol or the colloidal solution of a arsenic sulfide. Okay, and you have two electrodes to this end of the U-shaped tube, and when you apply the potential across the electrode, it is causing movement of this particle of the sol to the oppositely charged electrode. Due to this electrical potential, the particles are moving towards the positive electrode. That means this sol is carrying the negative charge particles. And you can see the sol level, which was at this point, it is increasing at the another side and decreasing at this side. So this property can be used to remove suspended impurities. So suspended impurities, if you apply the electrical potential under the influence of this electrical field, this impurities are moving to another side and get separated out from the solution, and you can get the clear liquid. Coating of this metal plates or metal rod, you can mount here the plates, can take the solution of paint under the influence of electrical field. This paint molecule getting coated on it and they are forming the layer, and you can easily coat or paint a metal plate. Next you have is an electro-osmosis. Here we know that it is the solution which is moving. So in this case, we have again taken the U-shaped tube, and in this U-shaped tube, you have taken a wet clay which is negatively charged. Okay, so this is the clay which is carrying the negative charge, and you have filled the water in it. You have placed the electrode in the two arms of the U tube, and you are putting the applying the electric potential. So when you apply the electric potential, you will find that the water level is rising at one of the electrode end. Okay, so in this case, you have the clay which is the negatively charged. So the ions which are getting deposited around the clay are the positively charged from the water, and due to this electrical force, electrical influence, they are moving toward the negatively charged electrode. So what is happening when you apply the electric pressure which exceeds the zeta potential, diffusing layer disturbs and it moves and causing the electro-osmosis. We know that particle surface, if it is negatively charged particle, then you have the compact layer and you have the diffusion layer. So when you apply the electric potential, the zeta potential is getting disturbed. Zeta potential is contributed because of whom? Because of this diffusion layer or the double layer. When the ions are moving, the solution is moving. That is the principle, that diffuse layer is disturbed and the diffusion layer ion are moving toward the opposite side electrode, which leads to the electro-osmosis. Now this osmosis is basically removal of water or removal of the solution. So it is used in many drying processes. So removal of water from the pit is one of the example for the application. Then in dewatering of the moist clay. Okay, so clay, if you want to dry, you can do dewatering by osmosis process where only the water is getting extracted and clay become dry. Then in drying of the various dye paste, you can use this osmosis the water molecules and help in drying of the dye paste. Like, share, subscribe my video and keep watching my videos